be good. All right, so I was just going to give a few notes on 4.1, 4.2, and 4.3. I looked through the, the class or the quizzes that you were supposed to take before class, and I also looked those that had started the assignments and just tried to see maybe where some misconceptions were, or maybe, if you left things blank or something, that kind of indicates to me that maybe you're not quite sure what you need to do there. I could be misreading that if you leave it blank, but hopefully, I can cover the things that way that you're still struggling with, and make sure that you have in mind any questions that you had on the homework. So make sure you're looking up those, and if we want to work through some specifically, I'm so happy to do that. Okay, so let's start with, we're going to be talking about polynomials, and so 4.1 basically talks a lot about just introducing what polynomials are. And so first, I want to make sure that everybody knows what that means, right? Polynomial, right? So there's two different kind of, root words, or I'm not sure, is poly a prefix? I mean, it is in this case, but I'm not sure exactly how that's considered, in English. But poly means many, and nomial means terms. So this directly translates to mean, something with many terms. So when we're talking about polynomials, that's what we're dealing with. So let me write down this polynomial, and then I'm going to pick out different parts of it and tell you about these, because I'm going to be using terminology that I want to make sure that you're familiar with, because sometimes that's where it can be a little confusing, is I don't understand what she means by, coefficient, or what she means by the leading term, or what descending order is, and stuff like that. So let's just go over a few of these things to make sure we're all together here. So if I have this polynomial, 3x to the 5th minus x to the 4th plus 8x minus 7. Okay. So anything with more than 3 terms is called a polynomial. Right? Now, there's other terms, like we'll see something called a monomial. Mono means 1, so that means 1 term. So like a 1-term polynomial could be like negative 3x to the 5th. Okay. Also, you'll hear the word binomial. Bi meaning 2, so 2 terms, so maybe something like 2x plus 7. Right? And then also trinomial. Tri meaning 3, so maybe x squared plus 3x plus 5, or something like that. Okay? So 1 term, 2 terms, 3 terms, but if it has more than 3 terms, we just call it a polynomial. They don't have any special names to it. So since this has 4 terms to it, so let me make sure everybody understands, first of all, what I mean by a term. So terms are connected with add and subtract signs. Okay, so that's why this one is 4 terms. And the sign that is in front of that term sticks with it. That's part of that term. So that's why I kind of included that negative there in front of the x to the 4th, and that negative in front of the 7 there. So you remember that negative sticks with it. Okay, so each of these, right, are terms. Now, this very first term here is called the leading term. And we first have to make sure that things are in descending order before we can pick out what that leading term is. And descending order means that you're going from highest exponent to smallest exponent. So let me write that over here. So descending order. When I ask you to put something in descending order, you're going to start with largest. Maybe I'll say that a little bit different. Start term with largest exponent. Go in order until smallest exponent. Okay, so the one that I have written up here is in descending order. So look at, I'm just going to circle these. So I've got an exponent of 5, an exponent of 4. What exponent is on this next term, that 8x?
A 1?
Yeah, that one's a 1. So if it doesn't show there, right, if it's just x, that's really meaning x to the first power. And I'm going to also write something down here next to this one, because this is where some people get a little bit confused. This is like saying x to the 0 power, right? And, you know, to try and remember about properties of exponents, hopefully you are familiar with those from other math classes, but anything to that 0 power is a 1, right? So, so this x to the 0 power is just 1. That's why they don't show it there. That's why they never write x to the 0 power. But they will be asking you about that exponent on there. So make sure that you're clear, right? I don't know if that's going to look weird if I circle that 0 exponent there. But these are all of our exponents, right? And then we're also going to be talking about something called the degree, right? So the degree of the polynomial is one thing we're going to talk about. And that just means the highest exponent that there is, assuming that there's just one variable, which is the kind that we're going to be dealing with now. When you get to 1050, you'll be talking a little bit more in detail about degrees of polynomials when there's more than one variable in each term. All right, but the degree of the polynomial is just going to be the highest exponent. So on this one, the degree of our polynomial is 5 because it's our highest exponent. And then each of the terms can also have the degree, have a degree to them. And we'll talk about that a little bit more in the next example that I do. But when it says degree of polynomial, you're just looking for that highest exponent there. Okay. Also, another thing to know here is that the numbers out in front of our variables, right, are called coefficients. Now this one just says negative x, but remember there's like a negative, there's an invisible 1 there. So that's really, the coefficient there is a negative 1. This one's an 8, and this one's a negative 7. Right? So the numbers out in front, right, are called the coefficients. That's what all these are. I have here in orange. Okay, but this first one here, this 3, actually is called the leading coefficient because again, we're looking, this term has the highest degree, right? So that tells us it's the leading term, but so it's also going to tell us that this is the leading coefficient. And so I'll be using that word And so I just want to make sure you know what I mean when I'm saying, you know, leading coefficient. Let's see, what else do I want to talk about here? Oh, one other thing, this last one, that since this last term has the x to the 0 power on it, so it's usually just displayed as a number. It's also called the constant term. And that's because it never changes, right? It doesn't matter what x is. If x is 1,000 and I raise that to a 0 power, that's just 1, and then I take 1 and times it by -7, that term stays as -7 no matter what. So that's why we call it the constant term. So you'll see that in verbiage used sometimes too. Okay. Right, what questions do you have here? It might look like a bit of a mess, but I know there's just a lot of different parts to this polynomial that I want to make sure is clear, that you understand.
Can we cover the leading coefficient one more time?
Yeah. So when we're talking about like the leading term or the leading coefficient, you first have to make sure that you're putting your polynomial in descending order, and then whichever one has the highest exponent becomes our leading term. And the number that's out in front of that, this 3, is our leading coefficient. Okay, and I'm going to do an example here where we can so I can kind of test and see what you guys know about these different parts. Okay, so let's do an example, and then we can kind of see maybe where you're understanding or maybe where you need a little bit more guidance here. So first I want you to put this in descending order. Okay, so you're going to arrange in descending order first. And then I'm going to ask you some questions underneath here after you have put it in descending order. Okay, so here is our polynomial. Let me give you just a few minutes to try and answer these questions before we talk about it.
I have a question whenever is a good time.
Yeah, go ahead.
So whenever we do the descending order, is that only if it's asked?
Yes. Yep, you don't need to put things in descending order unless it tells you to. Yeah.
Okay. Yeah, because on the practice question, I put it in descending order, and then I was like, oh, it's not one of the answers.
Yeah. Yep. So it doesn't, yeah, so only put things in descending order when it asks you to. However, going forward from here, usually you're going to want to write things in descending order. It just makes it easier to keep track of things, but just on 4.1, you know, that's kind of the only time that you might not have to write it in descending order if it doesn't ask you to. So.
Okay, thanks.
Mm-hmm. All right, let's go ahead and try these. I want to do that 3, 2, 1, go thing on these so I can just kind of see where you're at. So I want you to first of all put in for part A, you know, just type it into your chat box, but don't hit enter yet, just so we can make sure everybody has had a chance to think about it. So part A, just enter into the chat box what you think the leading term is. All right, 3, 2, 1, hit enter. Awesome. Okay, most of you are saying 8x to the 6th, right? So the leading term includes the variable part, okay? So make sure that that's clear, like when I'm asking, right? But the leading coefficient would just be 8. So part B, you should have just 8 there, because the coefficient is just that number out in front. Let me write these down. So we've got, so 8x to the 6th is our leading term. Actually, let me rewrite these in descending order just to make sure everybody has it in the same order that I'm thinking of. So 8x to the 6th, right? Then we go to the next highest power, so plus 7x to the 3rd, right? But notice the power of 5 and the power of 4 is missing. That's okay, we're just going to the next one. And then the next highest exponent is 2, so I'll put minus 3x squared. Next one would be minus 4x, and then minus 13. Right? Okay, so that 8x to the 6th, that whole thing is our leading term. But the number out in front is our leading coefficient. So our answer for B should just be 8. Leave off the x to the 6th power, because coefficient just means the number in front of the variables. Okay, now let's try part C. So I want everybody, again, to type in, but don't hit enter yet. What did you come up with for part C? What is the degree of this polynomial? Okay, go ahead and hit enter now. Awesome. The degree, right, is the highest exponent. And so it looks like everybody got that. So the degree of the polynomial is 6. Okay, let's try part D. So the coefficient of the fourth term. Sorry, was somebody talking? Okay, so let's try part D, the coefficient of the fourth term. So everybody type that into your chat box. And then let's hit enter. Okay, so this is where I've got to be We've got kind of a few different answers. So I'm asking you to answer the questions, right? I said after you arrange it in descending order. So I'm looking at this one here in green. So when I'm talking about the fourth term, I'm talking about the fourth term in here, right? So that means the fourth term over is going to be that -4. So you've got to make sure that you remember that negative along with it, right? That negative sticks with it. And the coefficient, remember, is the number in front of your variable there. Okay, so that's the coefficient of the fourth term. Right? Okay, is that clear? Or I just want to make sure that that's everybody's understanding, because there were a few different answers on that one. And some of it was because you're looking up here at the black polynomial rather than the green one. All right, let's try part E now. Okay, so everybody type in, what did you get for the degree of the third term? We haven't quite talked about this yet, but I want you to go ahead and try and see what you think I mean. I ask you for the degree of that third term. 3, 2, 1, hit enter. Awesome. You guys are great. All right, so you can see that the degree, right, the third term here, the degree of just this term, right, is going to be 2, because the degree is talking about the exponent that's on it. So we can talk about the degree of either the whole polynomial like we did in part C, or the degree of the terms. Right, so the degree of the third term is 2. What about the degree of the fifth term? What would that one be? Go ahead and hit that into your, or type it into your chat box and hit enter. Oh, lovely. Okay, so the degree of that is 0, because remember, this is really saying x to the 0 power, right? So that's how we know that the degree of that one, of this whole term, is 0. All right, what other questions can I answer there for you, or explain maybe a little bit better on the different parts of these polynomials? You feeling better about that? Because as I was looking at the homework, there was quite a few people that left things blank on these type of questions, or you were missing them. So I just wanted to make sure we went through that. Okay. And then the other thing on 4.1 that I wanted to talk about is just making sure that you're really careful. So the question that we did on the warm-up, I'm going to just write that one here. Number 1 on the warm-up said this. Right, so this negative, when we're subtracting this, the first thing that we need to remember is this negative really means like a -1, and we've got to distribute that to everybody first. Okay, and I noticed on the last weekly review that we did, and if you saw some of my notes back to you, there were quite a few people that missed the one where it was, you know, you were doing like f of 2 minus g of 1 or something like that, whatever the question was, because you weren't subtracting that whole thing through. So actually I think it was on the one where it just said like f of x minus g of x or something.
It's on the left.
Say that again. Did somebody say something? Or is that just me echoing? All right, so if I distribute that through, right, then I'm going to just kind of write, you know, this distribute it out. Whoops. So I'd have negative 2x squared plus 5xy, and then minus 7y squared. And then from here, I need to combine my like terms together. Right? So I got a negative 3x squared and a negative 2x squared. So those can combine together to be a negative 5x squared. Right? Then I can see another like term I have is this xy. So 4xy plus 5xy is going to give me 9xy. And then this y squared term doesn't have anybody to add or subtract anything from it, so it just comes down as part of the answer. So that would be how you come up with that answer there. But be really careful to distribute that negative through. That's all I'm trying to point out on this, because that tends to be where mistakes are made on that. Okay. Is there anything that you can think of on the 4.1 homework that you tried to do that you would like some more clarification on? So I was going to move on to 4.2, but I wanted to take any questions that you have first. It looked like most people that were doing it, most of you were getting like pretty close to 100%. And those of you that weren't, it looked like you just had some questions. I hope I answered those and the ones that I've done. All right, let's go on to 4.2 then. If you find that you have a question, let me know. So 4.2 is where we're going to be multiplying polynomials. Right, so 4.1, you kind of talked about just what a polynomial is and then adding and subtracting polynomials. So 4.2, when you're multiplying polynomials, you have to make sure that you have, that you remember your, I'm trying to say, your properties of exponents. Because when you're adding and subtracting polynomials, you have to have like terms, which means you've got the same variables and then the same exponent on those variables. But when you're multiplying polynomials, you don't need the same thing. They don't have to be like terms. All right, so meaning if you have something like this, let's try this for first example. Here, if I said I wanted you to multiply 2x minus 3 all squared. So first of all, think about what this is saying. It's saying I'm taking 2x minus 3, that whole thing, and timesing it by itself. All right, so really, when you see something like this, you should write it out like this, okay? Because you're not able to distribute that power through. We can do that when it's connected by multiplication or division inside here, but it's subtraction inside here. So we can't just distribute that power through, right? It's telling us we have to take the whole thing, multiply it by itself. All right, so this is where kind of talk about the, the terminology FOIL. So the F in FOIL stands for first, meaning you're multiplying the first term of one binomial with the first term of the other binomial. So 2x times 2x is 4x squared. Well, how did I get the x squared? Well, this is an x to the first and the x to the first. When I multiply x's, I add those exponents together. All right, so make sure you have that as a 4x squared. All right, then the next part of our FOIL, so O in FOIL stands for outside, or outer, however you want to think of that. So the outer terms are going to be 2x and then negative 3. So 2x times a negative 3 is a negative 6x. All right, then my next part of FOIL, the I, this stands for inside, or sometimes people think inner, right? So we're going to do the two terms that are on the inside, so negative 3 times 2x, which is a negative 6x. And then The L in FOIL stands for last. So the last terms in each of the binomials. So -3 times -3 is a +9. And then you just want to make sure that you combine any like terms together that you have, right? And so I can see in the middle there, I've got some like terms, all right? So I'm going to bring down the 4x squared, combine my -6x, and another -6x, and -12x, and then bring down my 9. Okay. So that would be my answer there. And think about it, if you just tried to distribute that power of 2 through to everybody, do you see how you would get the 4x squared and you would get the 9, but you'd be missing this middle term there. So that's why you can't just distribute that through. Okay. And there is something called the box method that some people like to use. And it's up to you if you want to use it or not. I'll just show you here so you can see. And we can use it when we're factoring too. And that's what we're going to be talking about in 4.3. So when we're multiplying these together, this 2, so we're going to have like 2x, one of the terms, minus 3. All right, so that's like my first one here. And then the second one I'm writing down is 2x and minus 3. And then I'm just multiplying, you know, the row by the column. So 2x times 2x gives me 4x squared. 2x times -3 is -6x. 2x times -3 is -6x. And then -3 times -3 for this last box would be +9. So that looks like it's saying it's negative, but it's not. So our answer is 4x squared. Add those terms together along the diagonal because those are like terms. And then you'd have your answer. Okay, so some people prefer this method over the FOIL method here. Either way, I really don't care. Whichever way you think is going to work better for your brain to do this, that's what I want you to use. That's why I show you an alternate way that you can do it. Because some people are just more visual learners, and so having something like this box method just makes more sense to their brain. Okay? Questions on that first one about multiplying polynomials? All right, let's do another one. And this one I want you to try and do on your own and see what you can do with this. This time, we're not going to have two binomials multiplied together. We're going to have a binomial multiplied by a trinomial. All right, but you're still going to be using similar ideas. We can't call it FOIL because there's more than just, you know, 4 terms here. We've got more than that, but it's still the same idea where you're taking this x and distributing it to everybody, and then taking the -2 and distributing it to everybody, and then combine like terms. Okay, so go ahead and try that. Let me see where you guys get to. Let's see what you got on yours. The way I did this is I distributed the x through, right? I multiplied it by everybody in the trinomial. So I got x to the third plus 4x squared, right? Because remember, you know, when you have like an x, that's really saying like x to the first power times x to the first power, right? So that's where I get that 4x squared from. And then x times 5 is 5x. And then in orange, right, I distributed the -2 through to everybody. And then I just wrote that underneath here. And I lined up my like terms just to make it easier for me when I am, you know, putting those together and stuff. And so then I got x to the third plus 2x squared minus 3x and then minus 10. Is that what you guys came up with? Or is there something there I can help explain better? And again, you could do this one with the box method. I'll just quickly show it to you over here. Because again, like I said, some people just like the box method better. And I just, you know, I always want my students to do what works best for them. So I have my binomial, so that's going to be x minus 2. And then my trinomial, my x squared, my 4x, and my 5. And then I just go ahead and multiply those together the same way I did in the box above. All right, so I'll just fill these in really quick here. And then you're going to always be adding these up along the diagonals there where those like terms are. So get x to the third, combine the x squared terms together, combine my x terms together, and then my constant term. Okay, so it doesn't matter either way you do it, you should come out with the same answer. It just is a matter of preference, what people like to do there. Okay. All right, let's try one more on 4.2. And with this one, before we do this question, I guess, just remind you about a couple of things here, because these kind of show up. Remember that when you're asked to find the area of a rectangle, right, you're doing the length times the width. If you're asked to find the volume of a cube, you're doing the length times the width times the height, right? Because now it has 3 dimensions to it. So you're multiplying, right? When you're finding area, you're multiplying when you're finding volume. So if I gave you, so here is the next example here. I'm going to try and draw a beautiful cube here. All right, and then it might say that this side is 3x plus 1, this one is x plus 4, and this side here is 2x minus 3. And so when it's asking you to find the volume, it's asking you to multiply all 3 of these together, right? So you're going to be doing 3x plus 1 times x plus 4 times 2x minus 3. And since it is multiplication, it doesn't matter which order you write things in, right? If I put my x plus 4 first, that's okay, right? Multiplication is commutative, right? 2 times 3 is the same thing as 3 times 2. And that stays the same even when we have variables or not, okay? So let's go ahead and try this, but can I have somebody's help or suggestion on this, how do you think would be a good way to go about trying to multiply all three of these terms together?
Maybe do the first two, and then when you get that answer, multiply the third one.
Yeah, so multiply two of them together first, right? Because it can't really multiply all three of them together at the same time. So I like that suggestion. And I personally like doing the last two together, but it doesn't matter. You could do the first two and then times the other one there. It's probably just because I'm used to seeing things in a certain way. So I'm not multiplying anything here by my 3x plus 1. I'm going to multiply my x plus 4 and my 2x minus 3 together, right? So this is where I'm going to be doing some foiling here. So I'll do this times this is 2x squared. Right? And then I've got this times this is negative 3x. 4 times 2x is going to give me 8x. And then 4 times negative 3 is negative 12. All right, but this is still in parentheses because we're still having to take that whole thing there and multiply it by that binomial. Now you could just go ahead and start distributing the 3x through to everybody and then distribute the 1 through. Or sometimes people like to combine the like terms together first so we don't have so many terms to multiply. But it won't matter in the end whether you combine these together first or whether you distribute it through. You will get the same answer either way. Okay, but when I do that, just write it out. If I do get those terms together first, it'll look like this. And now I'll go ahead and try and multiply these all together. Right, so I'm going to take my 3x, multiply it through by everybody, and then the 1, and then combine my like terms. Let me give you just a couple minutes to do that one also, so that you can get there. All right, how did you do on that one? Have you hit the hand raise button if that's what you were able to come up with, just so I can kind of see how you all are doing with it. So just click on your hand raise button if you're able to get that right. And if you didn't get it, please ask a question if you're not sure, if you're not seeing how I came up with some of those numbers. Okay, and some people said they didn't quite finish. Sorry, should have given you a little bit more time. Okay, yeah, really hope. If you were on the right track, that is awesome for that. All right, well, let's go ahead. All right. right, let's talk about 4.3. We're going to be talking about factoring polynomials. And when you're factoring, it's basically you're undoing multiplying polynomials. Right? Whenever there's a way to do something in math, there's always a way to undo that. And so the opposite operation, or the opposite thing here, to undo it, multiplying polynomials would be to factor them. So first thing we want to talk about is the greatest common factor, because some of the questions that you have are just going to ask you to factor out the greatest common factor. Right? So GCF stands for greatest common factor. Right? And so if we look at an example like this, so if I have 6y to the third power minus 18y squared. Right? So first thing we need to do is figure out what is the GCF. What is our greatest common factor? Can somebody tell us what you think that would be?
6y squared.
Okay, and how did you get that? Can you tell us your thought process of getting that? Because that's correct.
Well, I was looking at what's the highest number that would go into both, which would be 6, and then the highest exponent, which is 2, since they both have a y.
So you meant the lowest exponent.
The lowest, yeah.
Yeah, the lowest exponent. Perfect, right? So you're looking for the largest number that divides into all of the terms, and then the lowest exponent for the variables. Right, is what you're basically looking for there. All right, so then so some of the questions will say state what the GCF is and then factor it. All right, so when you factor out, let me just kind of write it like this. When you're factoring out that 6y squared, what you're really doing is dividing both of those terms by that 6y squared. So that's on the outside, right? And then when I divide these out, it's going to give me what's left over inside. So 6 divided by 6 is 1. Y to the third divided by y squared is just y. Right? Because remember, when it's connected by division, you subtract those exponents. So I did 3 minus 2 to get that y to the first power. And then negative 18 divided by 6 is negative 3. And y squared divided by y squared is just 1. So there's no y's left there. So this would be your answer. And remember, you could check your answer by multiplying that through. So if I multiplied that 6y, right, distributed it through to both of them, I'd get back with what I started with up here. And so you can always kind of check it that way, right? Because remember, multiplying polynomials and factoring polynomials just undo each other.
So just so I'm clear, you divided by the greatest common factor.
I did. Yep, divided both of the terms, or if there's 3 terms, I'll divide all of the terms by it. Does that make sense?
Yes, thank you.
Okay, so let's try another one. And this one, you might have to look a little bit closer to figure out what that GCF is. Okay. So let me give you just a minute to figure out what the GCF is on this one. So let me give you a couple minutes to think about what would your GCF be on this one. Okay, I'd like you to write that into the chat box, just what you came up with for your GCF. And just wait a second to hit enter. Have everybody try. So what do you think the GCF is on this one? All right, 3, 2, 1, hit enter. Okay, good. A lot of people are, there's a lot of similar things, and this is probably one question that some of you have. Some of you have a negative taken out, and some of you don't. Okay, so let me just give you an idea. So on this one, we are going to take the negative out because the leading coefficient is negative. So let's just write over here, when leading coefficient is negative, factor it out as part of the GCF. Okay, so we're going to, so since...
I'm confused how we got the GCF.
Yeah, let's talk about that GCF. So remember, you're first going to look at just the numbers. Okay, so with the numbers, we've got negative 21, we've got 28, and we've got negative 14. So we want to know what is the largest number that can divide into all three of those terms. All right, and 7 is the largest number, but since that leading coefficient was negative, we're going to pull out a negative 7. All right, and then you're going to look at each of those terms separately. Let me do these like in different colors. So if I have my x to the 4th, x to the 6th, and x to the 9th, remember with the variables, you're looking for the smallest exponent because you can't take out more than what the smallest one has, right? We can't take out an x to the 9th out of all of these because our first two terms don't have 9x's to take out, right? So that's why we have to go with the smallest one. And that kind of confuses people a little bit there, right? So x to the 4th is going to be our next part of our GCF. Okay, then let's look at our y's. So we've got a y to the 3rd, a y squared, and a y to the 1st, right? And so again, the one with the smallest exponent is just a y. So y is going to be part of our GCF. And then let's look at our z's now. So we've got a z to the 6th, a z squared, and a z to the 3rd. Z squared is our smallest exponent. So that's what's going to come out as far as our z's go.
So we're not subtracting those exponents?
Nope. We're just pulling out what they have in common, or we're trying to figure out what every single term has in common, right? The largest thing that can come out of all of them. And I know it seems kind of backwards, but the largest amount of variables that you can take out would be the one with the smallest number. Is that making sense? What I'm saying there?
Yes.
Okay. So now remember, we're going to take, so now once we figure out what that GCF is, I'm going to take and divide every single part. So I'm going to divide each of these terms by the GCF that I just came up with. So I'm going to divide this first one by negative 7, x to the 4th, y, z squared. And the same thing on all these other ones. Right? Dividing them all by the GCF. Okay, so now let's look and see. So first thing we need to write down is our GCF. That's what's on the outside. So I've got this negative 7 x to the 4th, because this is what I'm dividing out of each of my terms. And then in the parentheses, this is what's left over after I divide each of the terms by that GCF. Okay, so on this first one, negative 21 divided by negative 7 is a positive 3. X to the fourth divided by x to the fourth, well that's, you know, same thing divided by itself is just 1, so there's no x's left there. Y to the third divided by y to the first, right, would leave us y to the second. So this is where we need to do the subtracting of them, right, because we can see, okay, I've got 3 of them up on top, 1 on the bottom, so I'm really left with y squared on the top. And then with my z's, I'm left with 4 on the top, because again, I'm subtracting those exponents. Okay, what questions do you have at this point? I want to make sure everybody's with me there, figuring out what that first term was. Okay, go ahead and figure out what the next two terms are once you divide those out. And some of you might already have it done, but let me give you a couple of minutes just to see if you can come up with what the other two terms are. Okay, when you complete your part, look and see if that's what you came up with for those last two terms. Bless you. All right. Any questions there I can clarify for you now on these? Whether it's, does everybody feel like they understand how to find the greatest common factor? And then just how you're dividing each different part by that greatest common factor to get what's left inside. And remember, you can check it by distributing our greatest common factor back through. And when you do that, you should come back up with what we started with, right? Because remember, we're just undoing each other, right? Multiplication and division undo each other. All right, let's talk a little bit about factor by grouping also, because that's the other thing in 7.3 that we need to make sure you understand how to do. So on this one, it's just going to ask you to factor by grouping. So when you have 4 terms, I'm going to put that kind of here in parentheses, so you remember, whenever you have 4-term polynomial, good thing to always think about and how to factor it is to do this factor by grouping. Sometimes students are like, I'm not quite sure when to use factor by grouping. So kind of keep in the back of your mind or somewhere, write it down in your notes that usually things with 4 terms you'll factor this way. All right, so here is the polynomial. So if I have y to the third plus 3y squared plus 4y plus 12. So I have 4 terms here. So I'm going to, if I look and try and take a greatest common factor out of all 4 terms, there's nothing that all 4 of them have in common. But you do always want to look for that first to see if there is a GCF that will come out of all of them. All right? And then if there's not, then we're going to split it. So we have the first two terms and the last two terms. And we're going to just try and take out the greatest common factor of the first two terms and separately the last two terms. All right, so if I'm just looking at the first two terms, the y to the third plus 3y squared, right, my greatest common factor of just those two terms would be y squared. Does everybody see that? It's the greatest thing that can come out of both of those terms. And then in leftovers here, all right, I'm taking my y to the third, dividing it by y squared. That leaves me y. 3y squared divided by y squared just leaves me a positive 3. All right, so when I factor out that y squared, I'm left with y plus 3. Now I'm going to do the same thing with the last two terms. So what is the GCF of these two terms? Well, positive 4 is the only thing that I can factor out of both of those two terms. And when I do that, I'm left with y on my first term and a positive 3 on my second term. And now this is where the factor by grouping, like how we can actually get this into factored form. Notice that I have a greatest common factor now with both of these terms. Remember, terms are separated by add and subtract signs, right? So do you see I have two terms now? And the greatest common factor of both of those terms is y plus 3. So y plus 3 is factored out, and then we've got our leftovers that goes in the other parenthesis. So y squared and then plus 4. And you know it's in factored form because things are all connected by multiplication, right? We've got something times something else. This step here is not factored because it still has this, you know, we have two terms. It's not all in factored form. Factoring means that you have something times something else. Okay? All right, somebody asked, why is it y squared? Can anybody kind of say in your own words how you would think of that? Shut this door.
Because that first section has both a y, has a y by the third and then a y squared, so you would just take the y, because that's in both of them, and then the lower exponent.
Perfect. That's a great way to say it. I like that. Did that help, Simonia? Okay. All right, so then that would be our answer, would be y plus 3 times y squared plus 4. Okay, so I want to also show you, because I showed you with multiplying how to use that box method. Like I said, some people really like that method. So I'm going to show you how to use that when we're factoring, because again, sometimes people really like this. So I'm going to draw my box here. All right. And I've got 4 terms, so I need to have my 4 different boxes here. And then I'm going to just put each of those terms in the box. So I'm going to start with my y to the third, and then put my 3y squared next to it, and then go down to the next row, 4y, and then positive 12. And then here, instead of multiplying the two things together, right, we're looking at each of these columns and rows to see what they have in common. So if I'm looking at this first column, right, what's the greatest common factor of this first column? Well, it's only y, right? Y is the only thing they have in common there. Then if I look at that second column, right, well, what do these guys have in common, right? Well, the only thing they have in common is 3. Right? 3 can divide into both of these, and it's a positive 3. All right, now let's do our column, or sorry, our rows here. We just did the columns. All right, now we need to look at the rows. So if I do look at y to the third and 3y squared, all right, greatest common factor of those is y squared. And then let's look at 4y and 12. The greatest common factor of those two is 4, positive 4. So then you can see there's my answer, right? I get my y plus 3 goes in one of the parentheses, and then y squared plus 4 goes in the other parenthesis. And just to make sure it's clear, it doesn't matter whether I write it as y squared plus 4, like if I write that part first, and then write y plus 3 second. Remember, this is multiplication, right? And so how we write those down, it doesn't matter because it's commutative, right? So either answer is correct. There's not one that's like a better answer than the other. They're both great answers for that. Okay. Questions on that one? Let's try just a couple more here. So on this one, I just want to point out to you that sometimes things are not written in descending order, and it makes it a lot harder. In fact, it makes it impossible sometimes, not all the time, but sometimes it makes it impossible to try and do the factor by grouping. So when you see something like that has 4 terms that's not in descending order, I want you to put in descending order first. Because see, if I try and look at these first 2 terms there, the 4x to the third and negative 15, those guys don't have anything in common with each other, right? But if I rearrange them, then they will, right? So I'll have 4x to the third plus 20x squared, right? So I'm descending order, so I'm going highest exponent, next highest, and so on. Okay, so here's my 4-term polynomial now. I want you to take a minute right now, and you can either use the box method or just the standard method here to do this factor by grouping to get it factored. Okay, so go ahead and take a minute and try that. Okay, so on this one, the thing that maybe is a little bit tricky is this. Notice how this third term is negative. We've got a negative 3x. And so because we're kind of doing two different greatest common factors in the same problem, we're kind of thinking of this negative 3x as a leading coefficient. And so we've got to divide that negative out with it. Okay, so that negative becomes part of it. Because if you don't do that, if I was just to take out a 3, then I'd be left with negative x minus 5, and then my x plus 5 and my negative x plus 5 wouldn't match each other. And I need these guys to match up, right, so that I can complete my factoring there. So that's another thing. So if you see, oh, it's not matching up, look, you see, oh, do I need to take out a negative? That might help, okay? And with the box method, same kind of thing here, right? We're looking at this first column, right? And so for, oops, sorry, didn't mean to put 4 there. All right, so the only thing that these guys have in common is just an x, and the only thing they have in common in this column is just a 5. In this first row, they've got a 4x squared, and in the bottom row, notice how both of them are negative, so the thing that they have in common is that negative 3, right? They can factor out of each of those. So again, you get the same thing, right? Doesn't matter which method you do that, okay? All right, awesome. Sounds like one. Some people really like that box method. It just really is helpful. But like I said, just, you can just pick which way is easiest for you to do. So if both of them were not negative, then you wouldn't pull a negative out with it. So they both have to be negative if you're using the box method in order to bring this negative out. Because notice on our columns how we have a positive 20x squared and a negative 15. We didn't take out a negative because both of them weren't negative. Okay. All right. Okay, I want to do one more because this one says factor completely. So on this one, whenever it says factor completely, that usually is telling you there's probably a greatest common factor that you need to look at taking out first. And a lot of times students forget to do that. So let's look at this one. So if I have 72x to the 4th minus 36x to the 3rd plus 24x squared minus 12x. Right, so if I'm looking at this, I first want to see, right, is there a GCF that will come out of everything? All right, and that GCF is going to be a 12x. Right, 12 will divide into all these numbers, and each of them have an x that can come out. Right, so 12x comes out, and then let's see what we have remaining here. All right. So we'll end up there with 6x to the 3rd minus 3x squared. Right, I'm dividing each of these by 12x. All right, you can show it on your work or not. Some people, it helps them to just write that divide by 12x underneath each of them. Okay, and then plus 2x. And then minus 1, because negative 12x divided by 12x leaves you a negative 1. Make sure you still keep that number there. Okay. So my 12x stays out in front, and now I have 4 terms here, so I'm going to do this factor by grouping. Right. So when I look at these first 2 terms, I see, okay, a 3 can divide out of the 6 and the 3. And then x squared, right, has the lowest exponent there. So I'm going to have 3x squared comes out. What's left when I take out that GCF of these first 2 terms? Well, I'm left with 2x minus 1. Okay. And now again, and this is, I wanted to show you one like this because this gets kind of confusing for people because look it up here. All we have here is plus 2x minus 1. Right? But we've got to think about the greatest common factor that can come out of these, the 2x and the negative 1, is a positive 1. right? So there's always going to be something that can come out. It might just be 1 that can come out. And when 1 comes out, then we're left with the 2x minus 1. So I can see here now, okay, this is what I have in common, right? The 2x minus 1, so that's going to go in one of the parentheses. And then my leftovers in the other parenthesis are going to be 3x squared plus 1. And then I can't forget about this 12x up here. It still needs to be part of my answer. So 12x times 2x minus 1 times 3x squared plus 1. That's what I get there. Okay, so always make sure to, look for a GCF first. Is there something that can divide out of all of the terms? That's going to make the rest of your factoring a lot easier to do. Okay?